Is it showing now?
Yes, let me just clear this. So on the blockchain, it's like a computer system. TMI signal. Hence, gas. So now, Ethereum has the HDMI signal of Ethereum virtual machine. And signal machine is a computer system that can run several computer scripts that will be deployed to see. Now, you want to say computer machine. So for you to have a beginning state and end state, you have to pick a task. So immediately you deploy a transaction, it now takes the time and the knows when to stop the transaction so that they can have time for others. Now in terms of token and all of that, so Binance has their own blockchain. Now for performing transactions on their blockchain, you need to use their own native code to pay for before we pay BSC. Because if you start with CPNP and CPNP, that has a different symbol. Thank you. So there's because even if you check their symbol is very identical, but they are different. So that is what I need to ask. On Ethereum, we use F, not the Ether. That's the name of the coin of Ethereum. But their own network is called Ethereum. Now, for the easy for you to pay for gas, because sometimes I want to buy an NFT of $100, you pay $100 gas. What of that? So don't come into police. And on the blockchain, we have something we call trilemma of the blockchain, which means for you to become a blockchain, you must trade off one particular thing. We have security, localization, and scalability. So Ethereum is building on scalability and localization, leveraging on Ethereum security. Why? That is why Polygon is now having a very cheap transaction. And the introduction of ZK. So you just see something like I believe after this whole program, please just go to one side, turn on the screen. Before you mention it, tell us what to do. So thank you so much. Thank you so much. I know we're having a wonderful time here. So please join our great having second keynote speaker. And the beautiful thing, I'm excited to be addressing some of these questions we have. So you'll be speaking on blockchain security, how to
Who shares like this?
It's him.
Mr. Yusuf is the CEO and co-founder of Moroccan Blockchain Laboratory.
But he has already confirmed that he can hear us. So in case if somebody has a question, so it's to confirm. I'm guessing we can hear him. I think so. I think everything is connected.
Outside.
Outside this.
Joining us on Oracle.
We should be able to hear. Is he speaking?
Hello? Yeah, can you hear me?
He's speaking from here.
Yes.
Yeah. Okay. So
No.
good morning, ladies and gentlemen. Today I'm going to present a hot topic about blockchain and smart contract security. I'm glad that I had this opportunity.
Can you hear?
We can't get from us.
You can't hear from
Yeah,
outside.
yeah, I hear you. Do you hear me?
To the speaker, but this is where it's showing on the screen.
It's just the speaker.
Just the speaker. Please tell him to stop.
Yeah. Hello, can you hear me?
So lucky to.
He did it too. I don't understand.
Hello?
Please, can you hold on?
This, hello, can you hear us?
Yeah, I hear you. Can you hear me very well?
We're trying to make the speak up for everyone to hear. So just give us a few seconds and use mic.
Okay, yeah.
Let's see when we can.
Resolve this thing.
Can you put microphone beside you? Yeah, try it, let's
Ask me to speak. Can you speak now, please? So you have to change it from your phone. Your just when you connected that. Okay, no, I know what happened. Don't worry. I know why. Okay, great. So this is why.
try the speaker now with the mic.
He would hear us. We can hear him now. He can speak.
Hello. Can you hear me now? Hello?
Can you hear from outside?
Yeah, I hear you. I hear you. Hello? Good morning. Hi. Hi. Hello? Hello? Can you hear me? Hello? Hi.
Hello?
Hello? Okay.
We can hear you.
Yeah. I heard you. Yeah. Can you mute the mic? Your mic? Okay. Yeah. So yeah, good morning, ladies and gentlemen. So today I'm going to present a hot topic about blockchain and smart contract security. I'm glad that I had this opportunity to work on this wonderful and amazing hot topic. I would like to thank you and thanks Nigeria Ethereum event and the Roadshow workshop to Istanbul DevCon Connect. So who am I? So I'm a CEO and co-founder of Moroccan Blockchain Laboratory. I work as an ex-SOC analyst and the ex-pen tester at Bank al Maghrib, and I'm a bug bounty hunter on Web2. I find many critical vulnerabilities in Netflix, Google, Facebook, Viator, TripAdvisor, United Airlines. So some of them I get paid for these vulnerabilities. Some I didn't. I'm a meme addict. You will notice that during my presentation. And let's get started. So before getting into business, let's discuss this wonderful idea from Ivan Bugari. So Ivan Bugari is ex-developer, software developer at Google and Yandex, which is like Google in Russia. So imagine trying to hack Bank of America, and except you can read all the code in advance, and all of these transactions are public. And if you steal money, it is irreversible. That means, first of all, the blockchain, everything is blockchain is public, so everyone has this opportunity to see what happened in the blockchain, and you can see the code. So smart contracts, the code of smart contract is public, so everyone can see the code. And if you are if you have like this knowledge, you find vulnerabilities in the smart contract, you can exploit them and you can win money. So you can do transaction. However, the transaction are irreversible. That means when you send money to your wallet, it is really hard to make it. It's impossible to get to reverse the money. So it's like a paranoid. That's why developer deal with that every day. So smart contracts. In smart contract in Ethereum blockchain, we have what we called Solidity. So Solidity is object-oriented programming language. It's like C++ and JavaScript, but using money. In JavaScript and C++, you don't use money, but here in smart contract, you use money. That's why it is really sensitive when you deal with smart contract. Yeah, so Solidity is really easy, is nice, nice writability and the readability. And Solidity is compiled language, so you can translate the code into bytecode in order to execute it in EVM. Solidity is widely used by platforms like Uniswap, Ethereum, Hedera Hashgraph, Polkadot, so Tron, Zcash, Avalanche. And Solidity is easy to read and contain like ERC, Ethereum requests, like this ERC20 for token and ERC2721 for NFTs. So Solidity, one of the biggest advantage of Solidity is that the community is well established and you can find videos, tutorials, Stack Overflow, so you can ask a question and you can get an answer as soon as possible. So, and a lot of tools available like OpenZip library, like Travel, Hard Hat. Now people are going to I are going to 1 second. Yeah, my camera is broken. That's why I don't use the video. So the Solidity has many cons, like it's a new language. That means there is a lot of security vulnerability that are not discovered yet to be discovered. And the syntax from one version to another, it's a big difference from one version to another in terms of syntax. And developers have less vulnerability, less experience. Most of developer has like 3 years, 4 years of experience. So there is like what we call a lack of skilled people in this programming language. And this programming language contain like some really critical vulnerabilities like overflow and underflow for arithmetic. So this Solidity language doesn't check, for example, overflow, underflow vulnerability. I will talk about that in a few slides. And this problem was solved in Solidity version 0.8.0. So yeah, Solidity. Yeah, we have like dApps and apps. So this is like this is the decentralized application, and we have like traditional application. For traditional application, we have front end, and the back end is like your web server, and the back end, and you have like MySQL or SQL database, SQL database. But in the decentralized application, you have the front end. It's the same like the traditional web application, but in the back end we have blockchain. That's why people misunderstand the blockchain. So what is a blockchain? Blockchain is not a mystery. Blockchain is a database. So in order to solve, in next, like for example, when they ask you about what is blockchain, most of people think like blockchain is a network. Okay, yeah, blockchain is a network of database, but it's just simple database, decentralized and distributed database. You can visit like here in dAppsRadar.com, you can visit some dApps. For example, like you can find dApps for marketplace, dApps for game, DeFi, gambling, etc. How this is the use case of smart contract. So people want to invest their money. Like we have here, these people want to invest their money, but they are afraid to be scammed by contractors. So these are contractors. So thanks to smart contract, this problem was solved. So now we won't give this money to the we give this money to smart contract, and if the goal is met, so the contractor get paid. If the goal is not met, we get our money back. So there is no scam, no rug pull in smart contract, and code is law. Everything is written in the smart contract. You can verify it. You can take this smart contract and you can call for audit, like for example,
Hello.
audit
Hello.
fair. Yeah. Hello.
Yeah, please. I think we lost you in the general page. Just give us a few seconds, please.
Okay.
Thank you.
Yeah.
Hi.
So tell him we're going to tell him what's going on. I'm trying to fix some.
So we're trying, the cable is shaking, so we're just trying to get it fixed. 1 second, please. I think he can speak now. He can go on.
Okay, so can we have another person? Yeah. While we fix. So, no, allow the Ethereum guy to go. You should got black one. No, he's not. Just let them know. We have a second session.
We apologize for that technical issue. So we have a lot, and we are going to inform that. So while we wait,
Can you mute it? Can you mute your here? Nothing just continue. It's fine. Let's mute your. So tell him to continue.
Hello. Yeah. So this is a case study of smart contract.
Just mute it or you
Yeah.
go on. Or you go.
Hello. Yeah.
Continue, please. You're recorded.
Yeah. Okay. Yeah. So this is a case study of using dApps. So between contractor and people. So here people are afraid to invest their money in order to not be scammed by the contractor. So thanks to smart contract, this problem is solved. So in order, you don't give your money to the contractor, you give your money to the smart contract, and the smart contract will check if the goal is met, so the contractor gets paid. If the goal is not met, you can get your money back. And this is the smart contract. The code of smart contract is available to anyone, so it's public, so you can verify it on your own, or you can apply, for example, for an audit from an audit firm, and they can check it for you. So I will show you in few slides how to audit a smart contract. Smart contract and the traditional web application Like for example, in web application, we have what we call most common vulnerabilities like OWASP, Open Web Application Security Project, like SQL injection, remote code execution, and all these critical vulnerabilities. We have the same analogy in decentralized application. We have what we call DApps. So DApps, or Decentralized Application Security Project Top 10. So we have like few vulnerabilities. One of them is reentrancy attack. I will tell you a few critical vulnerabilities in a smart contract. We have what we called in traditional app, we have metric or CWE, common weaknesses in enumeration. The same thing we have in decentralized application, we have SCW, which is registry smart contracts weaknesses classification test cases. In order to write secure code in OWASP, we have what we call ASVS, Application Security Verification Standard. The same thing, we have something in smart contract, we call a smart contract security verification standard. I will show you these things in details in few slides. So for example, this, as I told you before, the code is low, and the smart contract, everything, the code is public. So here we have encrypted data in this is SWC 136. So it's not gambling when you know you're gonna win. So here we have two players, player one and player two. So the code is public. So if you know the code, if you find some vulnerabilities, so you can win the game. And this is, in this case, is a betting game. So here in the code, there is a function. If the sum, so for example, the player one will bet on, for example, number 5, the player 2 should be a bet on number 6, because 5 plus 6 equal 11. That's mean it's an odd number, so player 2 will win. So the player 2 know that the player 1 bet on number 5. I will show you this in a demo now. Yeah. Okay, this is a demo. So we have, this is the code. This is the code of smart contracts. So we have the address, we have number, and here we have like require, which is a requirement that's message.value you should bid on 1 ether, and you should bid on 1 ether. If you bid on less than 1 ether, it will not accept it from you. And the player should have like message.sender, which is his address, and the number. For example, you bet on number 5, on number 6, or something like that. And we have like 2 players here. So if the count equal to 2, that means there is only 2 players. And here we have we have this line, which is if the number is odd, the player 2 will win. If the number is even, the player 1 will win. So, and this is the requirement function. And yeah, you delete. This is the game over. So after that, the player win, and the count is 0. So this is the Remix IDE. So now we compile it. So we compile the code and we deploy it. So now the contract is deployed. Here, we found it here. So now we will choose a new address. So 078, that's mean new address. So we will bid on 1 ether. We will bid on 1 ether. And the number we will use, like, for example, number 5. So let's play. So here we will see that player number 1 bid on number 5, which is mentioned here. So, and we will change the player. We see that's 89, 89.999. That's mean this is, he bets on 1 ether. That is 100 minus 1 minus the gas fees. And let's select the number, player number 2. He will bet on 1 ether too. Okay. He will bet on 1 ether, and yeah, he will bet, like, for example, on number 6. That's mean 5 plus 6, it means 11, which is odd number. That's mean player 2, we will win. He will win. So here we have number 6. So when we come back here, we see that player one has like 98 ether, but player two has like exactly like 101 ether. That means player two win the ether of player one plus the ether of player two, and minus the gas fees. And this is the game. So this is not cool, because you know the game, you know you can win, so you just wait for the player one to play. This is architecture of smart of dApps, decentralized applications. So the front end is HTML, CSS, JavaScript, like traditional application, but the back end is Ethereum blockchain or Solana. You can use whatever you want as a blockchain industry, blockchain network. So the browser, for example, when you want to buy something, so the browser will get a static file from the web server. You can sign the transaction using MetaMask, and you send it to the Ethereum using Ethereum node using HTTP JSON RPC protocol, and after that you confirm it, the user will confirm, and you send the transaction, sign it to the smart contract. So now we should move to audit process. So you can find the audit in my GitHub. I will share my GitHub at the end. So audit process may be broken in 9 steps. So for example, we have specification and documentation until the evaluation of fixes. So first of all, in the contract, you should know the scope. You should know how things work behind the scenes. So you should have everything about every information, how developers think, how they create this smart contract. So like here we have the scope, we have what this contract is for. Like the cryptocurrency here is Mana. This is a decentralized project. And after that, we move to the next step, which is static analysis. So the static analysis, you run a software or a script, like for example, Slater or Mythics or other software, and you can find vulnerabilities before you deploy them. But security, a full with the tool still a full, because here, yeah, like here in this example, the Mythics didn't find like no issue detected. Doesn't mean no vulnerabilities. It's can only for known vulnerabilities. And after that, we have like manual code review, which is like finding a needle on a stack of needle. It's very hard. You should have a level of knowledge in smart contract security, and in this contract tier 1, the role of the owner has the authority over the following function: update price to update the price of tier, and add the tier 2, add tiers to add any compromise to the owner account, may allow the hacker to take advantage of this. In general, we recommend centralized privilege or rules in the protocol to be improved via a decentralized mechanism. That means these two functions are centralized to one entity, which is not cool. So if this entity, or if the admin is if the owner is compromised by hacker, that means your smart contract is compromised. So I can change the price, I can add tiers, so I can do whatever I want. We move to phasing. So phasing is that you take your smart contract and you throw a bunch of information, and mean gibberish. So sometimes it's Arabic, sometimes it's English, or whatever you want. So it's not necessary to be like meaningful information, and you try to see if your contract behave in a good way or in a bad way. So sometimes there is some leaks, like for example with some leaks, or like invalid reason or something like this, memory leaks or failed assertion. So then we move to symbolic checker. So symbolic checking is checking a program correctness, find state model and equal specification. So here it's a little bit difficult, but you can use like these tools like Manticore and Mythic Suite tools. After that, we have formal verification. So formal verification, you take your smart contract and you take your documentation and you try to proving or disproving an algorithm intention relating to certain formal specification using formal method of mathematics. And we move to brainstorming with others auditors, like go fast, go long, go far to go together. So maybe you can have like more information than other people. Maybe when you brainstorm with your friend or with the other auditor, you can find something really interested. You can think outside of the box with your friends. And discussing the project with the project team. So when you find vulnerability, you should share it with developers. Most of cases, these vulnerabilities are features or are false positives. So you try to do like, for example, proof of concept. You try to discuss with the team, project team, and you try to come up with a suitable solution or fix for this vulnerability. But before, after that, you write, like, for example, a report. You write a report. In the report, you mention the vulnerabilities, the impact, the likelihood, and if it is high, low, critical, medium, all these kind of severity, and you write or you exploit scenarios like hacking scenarios, like proof of concept, and you share, and there's some remediation in short term and in a long term, and you should share it um, with the developers and the project team. Sharing will with the project team, and the report delivery should should based on NDA, non-disclosure agreement. So you should not share this information with any other people outside of the project of the company. You should share it only by people who are in the project. And when this is most happen, when developers fix vulnerability, for example, defined when developers fix vulnerabilities and you try to do, like, for example, redo audit or something, you audit for the second time, you can find something new vulnerabilities. So that's mean you were meant to patch vulnerabilities, not to create more. Which is most of cases happen. So always you check what you find and you can check again, maybe you can find something new. So coding best practice. So here I am based here on smart contract security verification standard. You can find it on GitHub. So they have like this information how to write secure code and not to make chaos in the Ethereum blockchain. So sensitive data in web application are stored in protected database. However, in the case of dApps, data are stored on public blockchain, and everyone can read it. So private variable are not private and not that private. So sometimes you write like unit private function or something like that, but people can see what happened behind the scenes. So the code is public, everyone can see the code. So don't write your password, personal data, token, and everything in the smart contract. In web application, we to publish things, we usually use front end or API. However, in depth, everything is public, so code function are public by default, as I mentioned before. And here the function, you should always specify the visibility of function, because in smart contract we have the function, we have private function, we have public function, internal, external. So you should specify the visibility of the function. If it is public, so that means everyone can access to it. If it is internal, so only you can access to it from inside of the smart contract. Here we are talking about randomness. So randomness in a web application is a matter of one function you call random. So in the smart contract, it's in case of smart contract are executed on many nodes in the same at the same time. So and they must be executed the same way. So you can't use any local parameter from one node. And the problem here is not easy to get a random number in smart contract. So for example, here every node will have a different random number. That means it is very, very hard to have the same random number. And in this case, you can do like pseudo random number, but when you use like pseudo random number, you should not your random number, you should not it should not be based on public information, like for example block number or timestamp or something like that, that everyone can know it. Overflow and underflow are quite common in dApps. So for example, if we take ERC20 token smart contract, which is a contract for managing token that has the same value in currency like dollars. So ERC20 is like for example, Bitcoin, Ether, or something like that. So it's a token. You can actually use this vulnerability to create decillion. Like here we have 3.7 or 10 to the power of 16. That means decillion or even more token in real life. It is like La Casa de Papel. So going to the Bank of Hispania, printing millions of euros and going out with legal money, because you know, if you use this underflow overflow attack, you can have like legit money. To avoid this problem, you should use, like for example, math library from OpenZeppelin, or use Solidity version 0.8.0 or greater, and always verify extreme value, max, and the mean. And this vulnerability is very critical, but thanks to Solidity developer, now we have like 0.8.0, so the arithmetic bug is solved. And here we have in dApp, we have what we called calling, for example, reiteracy attack. In dApp, you call a contract, and this contract will call another contract or your contract. Maybe sometimes you call your contract. So we have a loop, like you call a contract and this contract will call your contract. So we have a loop, but between just contracts. So sometimes it can be business logic problem. So that was the case in the DAO attack. So if you want to avoid this kind of attack, make sure to no recursive calls from untrusted smart contracts are available in your smart contract. Also, you should check results of function calls low level, like low level one, like send, because this function will then fail, they return 0. So you should always check the result. That means it's this attack is very critical, and it's like here we have like 11 billion US dollar of money stolen and this was in 2016. So always verify your calls, always pay attention to send and delicate calls. To conclude, security in blockchain and smart contract is like a big elephant in the room. We know the problem, but nobody wants to mention it. And here we see that big players join the game, like Google, Facebook using Metaverse, Libra currency, IBM, Hyperledger Fabric, Microsoft, and other NFTs solution like for Ferrari and other big companies now, like the BlackRock want to join the game of blockchain. We face some problems, but thanks to dedication and commitments and from ethical hackers and from developers, we can avoid some critical and most attacks, big attacks in the blockchain, because here we are talking about millions and billions of dollars of losses in the smart contract industry. And thank you very much for your attention. If you have any question, I'm happy to hear your question. Yeah, thank you. You have the floor.
Yeah. So guys, we just finished one of the sessions. Yusuf, from Roadshow, have a great time with us, opening our eyes to smart contracts. For all questions, please send it to us. So, we want to thank you very much for your time, making our time for this presentation. So we hope to have you physically here next time.
You're welcome, Enoch. I'm available in my LinkedIn or GitHub. So if you have any question, I will be happy to answer your question. Thank you. Thanks a lot.